So for today's example, we are going to talk about one short question belonging to the topic rounding and percentage error. So let's try to have a look at the setting of the question. That is, we are given a formula which is A equals to the product of two terms 2 sine c and also square root of x plus 17 over the denominator 64xy squared. At the same time, we are given three values of x, y, and z. So x is equal to 10, y is equal to 0.5, and also z is equal to 60 degrees. So for part A, based on those three given values, we are going to calculate the exact value of A. So the main idea is, based on the structure of the formula of A, we can try to consider the right-hand side. We can try to have the simple substitutions of values. So by considering the structure of the formula of A and also the values of x equals to 10, y equals to 0.5, and also z equals to 60 degrees, by simple substitution and copy the entire formula to the graphic display calculator, we can get the exact value 0.05625. So take the GDC TI-84 plus CE as an example. We can consider the use of the math button and then choose FRAC representing fraction and then choose the first option N over D. And this one will give us a template on our calculator screen so that we can type the numerator and type the denominator directly. So our answer in part A would be 0.05625. In part B, we are going to correct this number to two significant figures. Firstly, we are going to consider the position of the second significant figure. So we have to remember that we cannot consider the first few zeros to be any significant figure. We should start the counting from the first non-zero digit, which is 5. So 5 is the first significant figure. That means the next digit, 6, will be the second significant figure. Then we have to look at the next digit, which is 2. So 2 is less than 5. That means we don't have to add 1 on the digit 6. That means the answer would be 0.056, and we don't have to write down 2 and 5. So in part C, we are going to write down an inequality representing the error interval of this estimate. And as we are going to consider to construct an inequality representing the error interval, that means we have to find the error margin of this estimation. So for this estimation, 0.05625 will be the actual value or so-called the exact value, whereas 0.056 is the result after rounding off, which is the estimated value. And actually, the rounding rule will give us some of the hints to obtain the error margin. So let's try to consider the part B again. In part B, we are going to do the rounding correct to two significant figures. In this case, which is equivalent to do the rounding correct to 3 decimal place, which means 3 digits after the decimal dot, right? Then we can try to consider the number 0.001 in this situation, which is also the place value of the 1000th digit. And then based on this number, the error margin can be calculated by dividing this number by 2. So in order to obtain the corresponding inequality, we need the upper bound and also the lower bound of the inequality. Then we can try to consider the use of this, that is 0.056 plus or minus this error margin. That's why we got the lower bound 0.0555, that is the minus case, and then the plus case will give us the upper bound, which is 0.0565. And we have to remember one thing, that is when we are going to construct the inequality of this estimation, make sure that the equal sign must be appeared in the lower bound only, which is this one. Finally, in part D, we have another case of estimation. Case C estimates the value of A to be 0.055. Given that our actual value would be the same as part A, which is 0.05625. And we are going to calculate the percentage error in his estimate. So in order to obtain the percentage error of this estimation, firstly, we have to identify what would be the actual value or so-called the exact value, and what would be the approximate value. In this situation, we have the actual value, which is the exact value, VE, which is equal to 0.05625, where the estimated value would be 0.055. Then we can try to consider the use of this formula, that is the absolute value of the fraction VA minus VE and then over VE times 100%. That would be the formula of the percentage error. So the reason why there exists the absolute sign, that is sometimes VA can be greater than VE or vice versa, we just need the absolute value, which is the positive magnitude. By using the simple substitution, we have the absolute sign of the fraction 0.055 minus 0.05625, and then over the exact value 0.05625, and then the result multiplied by 100%, and then we got 2.22%, and this is the rounded result.